The James Webb Telescope spotted it just outside of our solar system. Fox 35's Esther Bauer explains how this discovery could help us learn more about Earth.
The James Webb Telescope has just made a new discovery that alerted our reality, changing everything we thought we knew about the universe. From distant galaxies to strange cosmic signals, this finding has shocked scientists everywhere. What secrets is the universe finally revealing? Could this discovery hold answers to life beyond Earth? Join us as we explore the details. James Webb Telescope and its groundbreaking discoveries. The James Webb Space Telescope, often called Webb, is the most powerful space observatory ever built. Launched in December 2021 and fully operational by mid-2022, it was designed to look deeper into the universe than any telescope before it. Using a massive gold-coated mirror and highly sensitive infrared instruments, Webb can capture faint light that has traveled for billions of years. This ability allows scientists to see some of the earliest galaxies that formed after the Big Bang, giving us a direct look into cosmic history. Webb's discoveries have already been extraordinary. It has revealed galaxies that are far older and more massive than expected, challenging current theories of how the universe evolved. It has studied the atmospheres of exoplanets, identifying key molecules such as water vapor, methane, and carbon dioxide, ingredients that may be linked to the possibility of life. It has also given us breathtaking images of star formation, stellar nurseries, and massive dust clouds, helping astronomers understand how stars and planets are born. What sets Webb apart is its ability to see in the infrared spectrum. Unlike visible light, infrared can pass through clouds of gas and dust, exposing details that were hidden from telescopes like Hubble. This makes Webb a tool not just for imaging the distant universe, but also for studying the chemistry of nearby planets, moons, and comets. It has already uncovered details about objects within our own solar system, from the icy moons of Jupiter to the rings of Saturn, offering new insights into their structure and composition. The telescope is not only confirming what astronomers already suspected, but also presenting mysteries that no one expected. Some findings have forced scientists to reconsider long-held models of galaxy formation, star evolution, and even the timeline of cosmic history. Every new data set brings the possibility of rewriting parts of science we thought were settled. But in August 2025, Webb recorded something unlike anything before. A signal buried deep in its data forced scientists to reconsider not just the universe's history, but our place in it. This is where the story of 3I/Atlas begins, the signal that would not disappear. The James Webb Space Telescope usually delivers clear data that leaves little room for mystery. But in the first week of August 2025, something unusual appeared. A technician scanning frames from the NIRS-PEC detector noticed an odd flicker. It was not a spike, not the usual cosmic ray interference, but a pattern. At first glance, it looked like calibration noise, a faint pulse appearing at exact intervals, stretching across the infrared spectrum. The timestamp read August 6, 2025. Following protocol, every anomaly is logged and sent through the reduction pipeline. Most vanish after recalibration or artifact checks, but this one refused to disappear. Every attempt to rerun the data showed the same thing. Later that evening, another analyst working the late shift re-examined the results. The repetition was still there, undeniable in its rhythm. The pattern's symmetry did not resemble known errors, nor did it match solar interference. It aligned with none of the familiar cometary lines. No water vapor, no carbon monoxide, just a persistent rhythm in the carbon dioxide channel, ticking like a clock. As more people noticed, the case became impossible to ignore. By the end of that week, staff from different agencies had compared notes. Every check confirmed the same structure. The intervals always fell on whole seconds, repeating with exact precision. Nothing in the telescope's vast archive had ever displayed this type of rhythmic order. When the coordinates of the object responsible were traced, questions multiplied. Was it a new type of comet or something beyond the usual categories? The raw frames, still locked away from the public, began to worry those responsible for the telescope's data. Just a month earlier, on July 1, 2025, The Atlas telescope in Chile had registered an object moving against the stars. The minor planet center flagged it almost immediately. Its orbit was hyperbolic, meaning it came from beyond the solar system. The designation was given 3I/Atlas, only the third interstellar object ever confirmed in recorded history. The two that came before, Oumuamua in 2017 and Borisov in 2019, were strange in their own ways. But this newcomer brought its own set of puzzles. Dr. Lin, an orbital analyst at the MPC, led the effort to verify its path. She compared new images from Atlas with earlier frames from TESS and ZTF. The object's path could be traced as far back as mid-June. Each measurement refined the trajectory. The inbound speed, solar approach angle, and perihelion showed a clear story. The object was not bound to the sun. With an eccentricity greater than 1, it was guaranteed never to return. What stood out was the precision of its path. Its entry vector aligned almost perfectly with the solar system's ecliptic plane. For a random interstellar visitor, such alignment would be extremely rare, expected only once in hundreds of cases. But here it was, threading through the system like a needle through fabric. Simulations ruled out gravitational assists or a local origin. It was moving too fast, too straight, and could not be captured by any planet's gravity. Then came the shock about its size. Brightness estimates suggested a body nearly 46 kilometers across, far larger than either Oumuamua or Borisov. This was no small, icy fragment, but closer to a minor world. Dr. Lin's summary was simple: hyperbolic, inbound, and active. Observatories worldwide quickly turned their focus on the object, yet instead of answers, the first spectra only raised more questions. Comets usually become active when water vapor starts sublimating under sunlight. At 6 astronomical units from the Sun, beyond Jupiter, solar heating is weak and activity is limited. But 3I/Atlas showed something entirely different. Its spectra revealed no water vapor, no carbon monoxide, only a sharp carbon dioxide signal, far stronger than anything seen in known comets. The numbers were checked and rechecked. Ratios remained the same. Dr. Anders, a spectroscopist at ESA, described the result as bizarre. In every exposure, carbon dioxide dominated. The usual bright water lines were lost in noise, while carbon monoxide was absent altogether. Nothing in known cometary chemistry matched this. Established models failed. Sublimation curves, thresholds, and formation theories could not explain such behavior. Even the most exotic scenarios struggled to make sense of an object this large and active, venting only carbon dioxide so far from the sun. Teams at NASA and ESA tested the data pipelines for errors or contamination, but every result confirmed the same thing. Independent observations by SphereX later supported the finding. It was carbon dioxide and nothing else. Dr. Anders summarized the mystery quietly in an internal note. If this is a comet, then it is unlike any comet ever studied. The challenge was not only explaining why it was powered solely by carbon dioxide, but also why every other expected molecule was missing. The object seemed designed to keep its secrets in a single spectral line. By August 6th, the James Webb Space Telescope had performed another NIRSPEC session on 3I/Atlas. But instead of being released as usual, the files were placed under restricted access. In the official archive, the logs showed only a gap. There were no thumbnails, no quick-look spectra, just a placeholder. Requests for the data returned nothing but error codes. Inside ESA's Operations Center, leaked memos described an embargo on the images. The reason given was unverified anomalies in the comet's coma structure. But according to the same memos, what the raw infrared images showed was startling. The carbon dioxide emission formed a nearly perfect concentric halo, symmetrical to the limits of the telescope's resolution. No tails, no jets, no irregularities. Just a luminous ring centered on a bright core. Internal reports compared the pattern to synthetic models, but found no natural explanation. Fragmentation, solar wind, or rare outbursts could not account for such flawless symmetry. At the core, The brightness rose above what solar heating could explain. Again, no water or carbon monoxide was seen, only carbon dioxide. The custodian's memo ended with troubling questions. Why would a comet vent only carbon dioxide? And why would the gas arrange itself into such a perfect shell? The shape beneath the halo. In the telescope's deepest frames, analysts noticed something stranger still. A faint, rotating shadow seemed to sweep across the core of 3I/Atlas. It was not a dust jet, not a fragment trail, but a straight, linear band visible only in the mid-infrared. With each exposure, the shadow flickered along the same axis, shifting with the object's rotation. At first, analysts at ESA thought it was a processing glitch, but as the data was checked again and again, the shadow proved real. No natural comet had ever cast such a feature. For the shadow to persist through the glowing coma, the material beneath had to be dense, not porous ice. It would need a solid shell thick enough to block infrared light, but porous enough to allow carbon dioxide to escape. The numbers hinted at something hollow, possibly even metallic. The geometry was too precise for fractured rock. Simulations tested minerals and dust configurations, but none fit the observed pattern. Dr. Rami, a planetary engineer, suggested an unsettling idea. If the nucleus was hollow, then the shadow could be caused by internal structures, ribs, scaffolding, or even rotating machinery beneath the surface. The uniform halo of carbon dioxide might not be natural at all, but engineered, a cloak designed to mask what lay within. The mass estimates left room for such a cavity. This raised a possibility far beyond ordinary explanations. Instead of being a comet, 3I/Atlas could be a shell, an asteroid repurposed for travel, hiding behind an artificial veil. The carbon dioxide halo, flawless and uniform, might serve as camouflage, scattering heat and disguising the object's true makeup. Every frame showed the same stubborn line, as if the emissions were carefully tuned. No other molecules escaped, and nothing broke the symmetry. The shadow, perfectly linear and rotating with the nucleus, strengthened the suspicion. For scientists used to natural irregularities, such precision was difficult to accept as coincidence. The silent countdown of 3I/Atlas. Each new observation made the situation harder to dismiss. The rotating shadow, the shell-like emission, and the absence of water vapor all supported the growing suspicion that this interstellar object was not a natural comet, but something far more engineered. The evidence came not from visible light, but from what was missing, pointing to a hidden mechanical core. To study it further, Dr. Malik, a specialist in time series astrophysics, was asked to analyze the James Webb Space Telescope data. She began by breaking the infrared signals into bursts, carefully mapping each spike against time. What emerged was unlike anything seen before. Instead of the irregular flicker of normal cometary outgassing, the pulses appeared at intervals of 2, 3, 5, 7, and 11 seconds. These were prime numbers, rising in exact order. Natural processes are expected to produce random, chaotic rhythms, yet here was a structured sequence that looked deliberate. Combined with the object's size, 46 kilometers in diameter, the data presented a puzzle. Large interstellar bodies are rare but possible. What was almost impossible, however, was the path it had taken. Dr. Malik ran simulations at the Minor Planet Center's computing cluster. The results showed that the chance of an interstellar body entering the solar system so neatly along the ecliptic plane was 1 in 500. Instead of a random flyby, it looked like the object was slicing directly through the plane of the planets, as if on a guided survey path. Between the prime number pulses and the highly improbable alignment, coincidence became harder to defend. Her report, shared only with a few senior astronomers, listed another anomaly. The pulse sequence was not fixed. Over 3 weeks, the timing shifted. At first, it showed simple single bursts. Later, it switched to paired bursts. By August, it reached a third stage, where 5 group signals repeated every 283 seconds. The pattern was evolving in phases. The memo warned that there could be 5 total stages, with the current cycle ticking down to a clear endpoint. This implied that the signal was not only a broadcast, but also a countdown. By August 7th, restrictions tightened dramatically. Internal access to all James Webb and SphereX data streams was cut to a select crew. Routine logins failed. Outside researchers were locked out, redirected to vague maintenance messages. The Minor Planet Center's live feed for 3i/Atlas dropped to a simple static update. Even public dashboards that normally tracked comets and published spectra went offline. Officially, no problem was admitted. Unofficially, a new directive had been issued. All data connected to the object was classified under the category of technological unknowns. Inside the Pentagon, the situation was handed to Colonel Reyes, whose specialty was orbital threat assessment. The urgency was clear. By that afternoon, the U.S. Space Force approved a rapid launch. The reusable X-37B spaceplane was prepared for its OTV-9 mission. Unlike past launches, there was no press release and no webcast. The spacecraft left Cape Canaveral quietly, its course altered mid-flight toward the Mars-Earth corridor. The path 3i/Atlas was expected to follow. No payload details were shared, and no public comment was made. For the first time, the most powerful telescopes on Earth were watching a visitor, while the public was kept completely outside. As August went on, the mystery deepened. Orbital fitters at the International Astrometry Consortium noticed small but precise deviations in the object's trajectory. These were not the random nudges caused by solar wind or gas jets. Instead, they were controlled adjustments, as if the object was steering itself. Each change brought it closer to the Mars-Earth corridor, a route no natural comet could follow on its own. Meanwhile, Dr. Vail, a molecular systems analyst, examined the strange emission data. The infrared pulses began revealing even more structure. The ratios between the peaks mapped onto sequences resembling motifs found in DNA helix patterns. First 3, then 4, then 7. These were not random spikes. Vail's algorithms flagged the similarities, and speculation spread quietly among colleagues. During the same period, the Deep Space Network experienced unexplained outages. Probes like Voyager and Pioneer briefly went silent for minutes at a time, each dropout occurring when 3i/Atlas crossed their line of sight. Engineers blamed solar activity, but the timing was exact and consistent. The evidence suggested the object was not only moving with intention, but also adapting and responding to its environment, as if aware of the attention it was receiving. In the entire history of astronomy, no comet, asteroid, or interstellar visitor had ever written its own map into the data. Yet 3i/Atlas appeared to be doing just that, leaving behind structured signals, prime number pulses, controlled trajectory corrections, and mapped overlays. The combined anomalies pointed to a simple but unsettling idea. The object was not behaving like a natural body. For now, all official records remain silent, and most of the raw data is hidden from public view. But among those who have seen the signals, the debate has shifted. 3i/Atlas is no longer treated as just another interstellar comet. If you enjoyed this video, like and subscribe, and also click the next video shown on your screen.